Hello everyone and welcome back to my channel, Math with Dr. War. Today we're going to be multiplying fractions and also dividing fractions. Now we're going to start with multiplication of fractions. Now multiplication of fractions is the only time, and I'll repeat that, the only time you actually do what it says. You multiply. Now here's our first fraction. We have a half times 3 over 4, and we're going to multiply. And when you multiply fractions, you go straight across. So 1 times 3 gives us 3, and 2 times 4 gives us 8. And remember that unspoken rule, check to see if your fraction can be simplified. 3 and 8, the only number that can divide those is a 1. And if you divide by 1, your answer will remain 3 over 8. So whenever you multiply fractions, you multiply straight across and then simplify if possible. Now I made sure, because when you're taking the TASC test, I find students get a little bit confused about all the symbols used for multiplication. So I tried to put all the symbols in this multiplication of fractions. So sometimes they use the multiplication sign, not often. In algebra, we don't like to use the multiplication sign because it can be mistaken for a variable. But here, I'm using it. Okay, here I have 6 times 2 over 3. Anytime you have a whole number, make it a fraction. And to do that, you place it over 1. And again, we multiply straight across. 6 times 2 gives us 12. 1 times 3 is 3. And I'll be honest, sometimes your answer can be divided evenly. When you look at this, 12 divided by 3 is 4. So I know that 3 can divide 12 evenly. So your answer is just 4. Now, sometimes with multiplication, they like to use parentheses. This means multiplication. So again, we're going to go straight across. We're going to multiply 5 times 3, which is 15. We're going to come to the denominators. 9 times 10 is 90. Now I have 15 and 90. Both of these are divisible by 3 or by 5. Remember, anything that ends in a 5 or 0, you can divide by 5. So let's divide by 5 because that's the bigger one. So I'm going to divide by 5 for both of these. 15 divided by 5 is 3. 90 divided by 5 would give us 18. And again, let's look at our fraction. We have 3 over 18. Okay, we can reduce some more. I can divide by 3 and by 3. 3 divided by 3 is 1, and 18 divided by 3 is 6. You could have gone higher. If anyone out there saw that we can divide both of these by 15, you're great, you're awesome. But some people can't. So if you saw that 15 and 90 could be divided by 3, start with 3 because you don't want to give yourself a headache and you don't want to be in the test staring at the paper. And then keep going till you get smaller and smaller. Okay, here I have 3 over 5 all squared. Now the first thing you have to remember is that 3 over 5 all squared means 3 over 5 is multiplying itself twice. And remember, when you're multiplying, you go straight across. 3 times 3 is 9. 5 times 5 is 25. 9 and 25, the only number they have in common is a 1. And if you divide by 1, you're going to get 9 over 25. So always remember, when you see that exponent there, it means that whatever is inside is multiplying itself twice. Now, my college students usually see these types of multiplication. You have 15 over 4 times 12 over 5. Now, I have to admit, I am lazy. In a test, I don't want to multiply 15 times 12. If you want to do that, that is fine. But for me, I don't feel like multiplying 15 times 12 today. So what I'm going to do is I'm going to break 15 into its factors. I know 15 is 5 times 3. I know 12 is 3 times 4. So I'm going to write this as 5 times 3 times 3 times 4, like this. And then at the bottom I have 4 times 5, and then I'm going to look to see where I can cancel. We call this cross canceling. So this 4 cancels this 4. This 5 cancels this 5. So in my numerator, I just have 3 times 3 is 9 over everything in the denominator canceled. So that's a 1. And 9 divided by 1 is just 9. So whenever I have big numbers like this, I break them up into their factors to make them a little bit smaller. You could have done the 15, you can only do it as 5 times 3. And 12, you could have done it as 2 times 6. And 4, we could have broken that up into 2 times 2. And 5 is just 5 times 1. So I'm just going to put 5 because it makes no sense writing the 1. And then again, look to see where you can cross cancel. These 2 cancel each other out. This 5 cancel each other out. When you multiply 3 times 6, you get 18. Notice that in the denominator, you just have the 2. And 18 divided by 2 is 9. So it doesn't matter what your factors are, you're still going to get the same answer. Remember, everyone sees different numbers, especially when it comes to factors. So multiplication wasn't that difficult. Let's look at dividing. Now when you're dividing fractions, I don't go through that long process. I have a method I call the butterfly method. The butterfly. I like this method, and I always show it to my students because I'm like, no one has time for that. You know, we're New Yorkers. We like everything fast and dirty, so no one has time for long methods. So I have a half divided by 4 over 5. So if you're dividing, I call this my butterfly method, and basically it looks like a butterfly. So here we're going to multiply. 1 times 5 is 5 over, and then over here we're going to multiply. 4 times 2 is 8. And my answer is 5 over 8. I am finished. Wasn't that wonderful? Let's try it again. 3 over 10 divided by 9 over 10. Okay, let's do our butterfly. So it looks like these look like the butterfly wings. So you go this way diagonally and we multiply. 3 times 10 is 30 over. And then when we go diagonally this way, we have 10 times 9 is 90. Okay, can you simplify this? The answer is yes. These zeros here will cancel each other off, leaving you with 3 over 9. And then you're like, oh, 3 and 9 you can divide by 3. So let's go ahead and divide by 3. And our answer is a third. Excellent. I have 5 divided by 2/3. Again, make this a fraction, put it over 1. And let's do our butterfly method. So going this way diagonally, because you're starting here from the 5 that you read in a book. 5 times 3 is 15 over, and then diagonally this way. 2 times 1 is 2, so I have 15 over 2. Can we simplify this further? The answer is no. And we're going to leave our answer as the improper fraction. In algebra, we do not like mixed fractions. Leave your answers as either proper fractions or improper fractions. Now, sometimes, and this will be like for my college students, sometimes you get fractions written like this. We call these complex fractions. Complex, yeah, they look complex, don't they? Complex fractions. It seems the mathematicians didn't like this method of writing their fractions. Now, if you're given a complex fraction, it's very simple. Some people teach it the way where they unpack the complex fraction and take you back to a normal division. Again, in the test, you don't have time for that. But here's a simple way to solve this. Now, look at my illustration right here. Your numerator and your denominator for your fractions are the crust. So the top is the crust and the bottom is the crust. Think of an apple pie, okay? The top will have a crust and the bottom will have a crust. And in the middle will be your apple and cinnamon mixture. So you multiply your crust, that's your numerator, and then the denominator is the mixture inside, which is the apple and the cinnamon. So let's take this for a run. So here I have 2/5, and this fraction bar here, this is the big fraction bar. Notice it's always longer than the others, which means 2/5 divided by 7/11. Okay, I'm going to write this out. So let me put my bar here. So the crust, which is the top and the bottom, tippity top all the way to the bottom, we multiply. 2 times 11, 22. And then we're going to multiply the middle, which is the 5 times 7, which is 35. So your answer is 22/35. We cannot simplify that any further, and that's our answer. Let's try it again. So I have my complex fraction here, which is 1/4, divided by 3/8. So remember our crust. This is the crust here and here. So 1 times 8 is 8. Over, and then we're going to multiply the middle, which is your apple and cinnamon. 4 times 3 is 12. And then always check to see if you can simplify. I know 8 and 12 are even numbers. Even numbers you can divide by 2. I always tell my students, don't give yourself a headache. I see all the time students are in a test and they're trying to simplify a fraction and they can divide by 2, but they're sitting there thinking for the biggest number. Don't give yourself a headache. I am a mathematician. I don't even give myself a headache. Once they're even, I'm going to divide by 2. Dividing by 2 is like halving. I say this in my class all the time. Half of 8 is 4, and half of 12 is 6. The numbers are still even. So guess what I'm going to do? I'm going to half again. Half of 4 is 2, and half of 6 is 3. Your answer is 2/3. Do not give yourself headaches. I see that all the time. Don't do it to yourself. It's not that serious. One more, one for the road. So suppose you have 3/4 divided by 5/6. So again, remember your crust. The crust will be the top number and the tippity bottom number. And we'll multiply. 3 times 6 is 18. And then the middle, which is the apple and the cinnamon, that sounds tasty. You're going to multiply that. 4 times 5 is 20. Here's our apple pie, folks. 18/20. Can we simplify that? Yes. They're even numbers. Even numbers are divisible by 2. Dividing by 2 is like halving. Half of 18 is 9. Half of 20 is 10. And your answer is 9/10, and you're finished. So if you ever come across a complex fraction, remember your apple pie. Crust at the top, crust at the bottom, and just multiply the middle, which is the apple and cinnamon mixture. Yum, yum. I hope this has been helpful. Good luck on your TASC examination.